Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to the International Public Lectures with the topic of Data Science and AI for Social Good. We wish to welcome our honorable speakers, Professor Wayne Wapp, Associate Professor at School of Computer Science and Engineering of University of New South Wales, Australia, Professor Setia Pramana, SSE PhD, Associate Professor at Polytechnic Statistika STIS Jakarta, Ibu Sarini Abdullah, SSEM Stats PhD, who is going to be our moderator for today's discussion, Professor Al-Hadi Bustamam, SSEM Com PhD, Head of the Department of Mathematics, Faculty of Mathematics and Natural Sciences, Universitas Indonesia, Dr. Rerum Naturali Budiawan, Deputy Dean of Education, Research and Student Affairs of Faculty of Mathematics and Natural Sciences, Universitas Indonesia, Ibu Siti Maria from Polytechnic Statistika STIS Jakarta, Dr. Randa Titin Siswatining DEA, Head of the Statistics Study Program in Faculty of Mathematics and Natural Sciences, Universitas Indonesia, Dr. Dipo Aldila, SSEMSE, Manager of Research and Community Service of Faculty of Mathematics and Natural Sciences, Universitas Indonesia, all of the honorable lecturers of Universitas Indonesia, and all of the participants of our public international lectures. My name is Adawia Ananda. I am a student of statistics major in Universitas Indonesia, batch 2021, and I have been privileged with the opportunity to become the master of ceremony for this event. On behalf of the host, we would like to extend our greatest appreciation to each and every one of you for being able to attend this event. Ladies and gentlemen, please allow me to inform you of this afternoon's program. We will start the lecture starting with Professor Wayne Wapp with the theme of AI for social good. Next, we will continue with the lecture delivered by Professor Setia Pramana with the theme of AI for official statistics. Following the lectures, we will conduct a discussion which will start at 14:35. And lastly, at 15:05, we will have a closing session to finish off this event. Ladies and gentlemen, moving on to our first agenda, we will have an opening speech delivered by the head of the Department of Mathematics, Professor Al-Hadi Bustamam, SSEM Com PhD. To Professor Al-Hadi, the time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon for all of us. First of all, we would like to thank to Almighty God, Allah Subhanahu wa Taala, and also our blessing to our Prophet Muhammad Sallallahu Alaihi Wasallam. It is a very great honor for us today. We have Professor Wayne Wopki from University of New South Wales and also Professor Setia Permana from Sekolah Tinggi Ilmu Statistik Jakarta. First of all, we would like to thank to our Vice Dean, Pak Budiawan, for your great time to come to our general lecture today. This general lecture is conducted by a study program of statistics from Department of Mathematics, Universitas Indonesia, and also I would like to thank to Pak Dipo, our manager on research affair in our faculty, and also for Bu Sarini and also all of the audience today. We have this similar hybrid seminar. We have on site around 100 students, and from online we have more than 100 participants from all of area, including from other university in Indonesia as well. It is it is a good chance for us to know each other, because in our department we have many study program now. We have mathematics, statistics, actuaria, and also master of mathematics. Then, and in that study program, we have some focus or major research topic in data science, yeah, and artificial intelligence. We have also some laboratory, like laboratory of bioinformatics and advanced computing, and who already established many research in the field of life science, and using some of data science and AI approach. And our faculty also, we have data science center who already conduct some collaboration with many industrial or institutional partner from around of Jakarta, and also from other university outside. So I think it is a good time for us to initiate in future collaboration for this data science and also artificial intelligence field of study. I would like to ask Pak Budiwan to officially open this seminar. Thank you very much. Has a nice seminar today. Assalamualaikum warahmatullahi wabarakatuh.
This okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So far, I would like to thanks to Head of Department Mathematics, Professor. What I forgot it. My college. Sometimes I forget. Al Hadi Bustaman, of course, and also our manager, research. Professor Adi, because I am so close as a friend, so sometimes I forget it. I'm sure it's okay. And second, I would like to say thank you for our manager, research and community affairs. And also to audience, a very good afternoon. On behalf to the Faculty of Mathematics and Natural Sciences leaders, I would like to convey a warm welcome to Your Excellency, honorable speakers, distinguished guests, and ladies and gentlemen. I would like to start expressing my great gratitude to our honorable speaker, Professor Wayne Wopke, PhD from School of Computer Science and Engineering, University of New South Wales, Australia, and also Professor Setia Pramana, PhD from Statistics Polytechnic STIS, Indonesia. We are also thanks to the Department of Mathematics and also their study programs on statistics for the support and collaboration for this event. Let me take this opportunity to once again welcome all our guests and participants, especially rector and student in FMIPA Universitas Indonesia. We hope this general lecture will provide a meaningful platform for all of us to share perspective on how to sustainably enhance our academic and regional connectivity and unlock the potential collaboration of our regions, especially in the field of data science and AI. I believe this seminar will highlight the source of innovative ideas, concepts, and a breakthrough in the development of data analysis, big data analysis, machine learning, and deep learning models, and their application in the future, especially in the field of data science and AI. Ladies and gentlemen, Fakultas Matematik and Natural Sciences Universitas Indonesia have been working hard since the last few years to enhance and improve our capacity and quality in this field by reserving our curriculum and make some data science course as compulsory course in our faculty and become a major field of interest in the Department of Mathematics, including in bachelor's study program in statistics. Currently, we have magister program in mathematics with major in data science as well as data science center or DSC. As part of Lembaga Science Terapan, this is a collaboration board in our faculty in which focusing the work to create multidisciplinary research collaborations and innovation in this field with government and industry. I hope this event will also be remarked as the stepping stone to initiative and process of future collaboration between Faculty of Mathematics and Natural Science University Indonesia with University of South Wales and Polytechnic SDIS Jakarta. I especially thank to the organizing committee for their hard work in the preparing and organizing this general lecture so that it can go well, smoothly, and successfully. Finally, through this seminar, let us extend the network and cooperation between among stakeholders of the data science and AI community, especially in Indonesia and in the world in general. We hope many great event and future collaboration will hand in the near future with the support and contribution various parties. Last, I wish you all very successful guest lecture. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Now, hereby I was declare open this seminar.
We would like to express gratitude to Professor Al-Hadi and also Dr. Budiawan for the remarkable speeches and the official opening of this lecture. And to keep this wonderful moment, we are going to have a photo session together. So I invite all of the honorable speakers to please stand up so that we can document this moment together. And so to the documentation team, the time is yours. To all of the participants, please stand up for the documentation.
Udah.
Honorable participants, before we move on to the next session, please allow me to introduce our moderator for today's lectures, Ibu Sarini Abdullah, SSEM Stats PhD. Ibu Sarini is a lecturer in statistics of Department of Mathematics, Universitas Indonesia. Having delved into the field of statistics for more than 2 decades, Ibu Sarini specializes in Bayesian statistics, medical statistics, survival analysis, and many more. Her expertise can be seen through the extensive list of research she has done on this field. Without further ado, please welcome our honorable moderator. To Ibu Sarini Abdullah, the stage is yours.
Okay, thank you. Good afternoon, everyone. It's such an honor for me to attend the meeting today. Okay. Sorry. Okay. Yeah. So today we have the seminar on data science and AI for social good, and I can guarantee for all of you who attend this meeting that you are spending your time wisely, because we have 2 excellent speakers in here that I will introduce shortly. So I think that I'd like to invite our speakers to come to the stage. First, we have Professor Wayne Wopke from the University of New South Wales. Please come to the stage. And also Professor Setia Pramana from Polytechnic Statistics. Steve, please come to the stage. Okay. Okay, then I just be standing here. Okay. Yeah, makasih Pak. Okay, so today our 2 speakers are already with us in here, and apart from this, the collaboration between the University of Indonesia and the chance given by Prof. Setia to hold this meeting, it is also relive some old memories, because I did my master's in statistics at the University of New South Wales. So it's really nice to meet you here. And then I wish that I can visit that university again one day. Okay, before we start the speech, I'd like to just introduce our speakers, reading their CVs. So the first one is for Professor Wayne Wopke. Believe it or not, you know that I got the file of 22 pages listing of, you know, his publications, books, and so on. And then I wonder if I can have that kind of CV one day. So Professor Wayne Wopke, as we introduced before, is a lecturer at the University of New South Wales, and then he has lots and lots of experiences in the research, including, you know, winning 6 awards from several institutions, and then also have had several visiting positions all over the place, and also he had lots of grants. I think that at least 24 four research grants. Oh my gosh, I don't know how you can handle it. And then lots of publications, including 4 books published by Springer Verlag. Most of them are in the AI, artificial intelligence, journal articles, several book chapters, and I think over 100 publications in conference papers, seminars, visiting, speakers, lots and lots of things he's been doing. And also has 5 patents from British Telecom, and also the editorial boards, reviewers from various international journals, mainly in artificial intelligence area. So that's why I say that I can guarantee that we can get lots of things today by attending this session. And also now I'd like to introduce our second speaker, that is Professor Setia. So Professor Setia is from the STIS, Sekolah Tinggi Ilmu Statistics. He graduated from Statistics, Universitas Brawijaya, Malang in 1999. Okay, and then he did his master's in applied statistics in 2006, and got also the master's in biostatistics in 2007. Wow, 2 masters. That's awesome. From Belgium, and also finished his PhD in 2011 from Hasselt University in Belgium as well. Professor Setia has again lots of experiences in doing research, starting from being an assistant researcher at the Hasselt University, Belgium from 2007 to 2011, and also doing postdoc in medical epidemiology and biostatistics in Stockholm from 2011 and 2014. And right now, Professor Setia is the Deputy Director of Statistics Modeling Development at BPS, and also the professors in statistics at Polytechnic Statistica, STIS. And his expertise is in his current research is in big data analytics and development for public policy, computational statistics, machine learning, artificial intelligence, and also statistical software developments. So I've been wondering if us can follow the path of our 2 speakers. Yeah, not in a short time, of course, but yeah, at least we can just start to try achieve some of their achievements. So I think that without further ado, let's just listen to their presentation. The first I present Professor Wayne Wopke. So please go ahead, the time is yours.
So thank you for the invitation to be here. It's a pleasure to be here in Universitas Indonesia. I've not visited your campus before. And thank you so much for the introductions. That's been tremendous. If you'd asked for the short version of the CV, I would have sent that. But Indonesia being very official, I've sent the long one. Just making me sound old, having done all this stuff over the years. But I could equally well have given the title of AI for official statistics, because when I was told that we were going to talk to statistics students, I thought we'd talk about something concrete. And this is work we've done very much in collaboration with BPS and STIS. And Siti Maria, who is here in the audience, is my PhD student at University of New South Wales, and has done a lot of the hard work. So my job as the supervisor is to ask questions, and Siti's job as the student is to give answers. So the talk today, we will talk about machine learning methods for poverty targeting, which is a question directly of interest to BPS, but also I want to emphasize that the talk works at 2 levels. So even if you're not interested in poverty targeting, I want to draw out some methodological issues that will affect statistics and data science generally, because you may not be aware that there are serious methodological problems and tensions and difficulties in actually applying and using data science and statistics together. If you could put it in a simple phrase, statistics is very much model driven. data science is by the name data-driven, and those things lead to very great differences. So we've got lots of slides because we've prepared a very long talk, but so some I will skip through. There's sort of two halves of the talk, and one is to emphasize about data quality issues, and the other is to look at some specific techniques, not that we're particularly focused on techniques. So we're going to look particularly at poverty targeting. I suppose you know what poverty targeting is, but we have to basically identify who is poor out of the poor households in Indonesia. And the way that's done is you typically do a household survey. So we're going to do it at a household level, the very hardest problem of all, which households are deemed poor, which households are not deemed poor. And typically, as you know, there's a survey run by Susanasa where the questions are asked periodically about food, education, transport, health, et cetera, as on the slide. So the current methods, they actually have divided up Indonesia into 514 kabupaten kota. So we'll call that a district in English. It's not exactly a district, and assume that household expenditure is distributed equally amongst the members of the household. But the short version is that the current methods, statistical and otherwise, have very high inclusion and exclusion errors. So that's one typical metric. So an inclusion error is people getting benefits when they don't really need them, and exclusion error is where people don't get the benefits when they do need them. So current methods are not very good. I think that's, so there's no guarantee that any method will work. So we've focused our studies on 3 districts of Indonesia, so very interesting districts, but of course there are 514 of them, Brebes and Surabaya. So 2 rural areas and 1 urban area. And what I wanted to show you here was the sort of basic data analysis that we always do, or I always say we should do, before we start plugging things into our favorite programs in R or Python or what have you. So have a look at these distributions of household per capita expenditure. This is done from the survey data. And you'll see, so the red line there is the poverty line as determined by BPS by some means, which we're not fully aware of. And the blue line is 40%. So some social programs, someone decided 40% was a cutoff. So 40% of households ordered by wealth should get some benefit and the other 60 don't. So the problem is to identify those. And you can see with these distributions that there's quite a lot of clustering around the mean. So this is really makes this a really hard prediction problem or an estimation problem. And there's like to be lots of mistakes made around the borderline, but it's good to know those distributions. It makes it, if it was somewhat spread out more, it'd be easier to do. Surabaya is different being in an urban area, and but there's still that large amount of clustering, a large amount of around the mean. So just to show you how bad this problem is and how long ago, so this is 10 years old. So notice that in this 10 years, there's not been a lot of work to improve these errors. So there's lots of work to be done, and I encourage everyone to get involved in this kind of work. So if you want to determine the bottom 40% of the population by wealth, then the error rate is about, and in this setting, inclusion and exclusion is the same because there's a group that swap out to get the benefit. So inclusion, exclusion matches. AusAid, Australia's aid department, estimated based on the raw data that they had access to that I don't, about 35% is the error rate that you get in Indonesia, and that conforms with our data as well. So this is a very serious and difficult problem. Oops, this way. So we talked about these assumptions before, and so it's a good idea to estimate these assumptions and evaluate assumptions. Now, this is the most important slide, so pay attention. If you decided to evaluate your methods as we have here, let's say you trained them on 2016 to 2019 data and test on the 2020 data you've collected from a sample of households, a lot of our students at UNSW think, oh, all I have to do is plug it into these methods and choose the best one. So if I were to show you this table in class, what would you conclude? Well, given we haven't got a lot of time, I'm going to tell you what you would conclude. And what you could conclude is that none of these methods do really much better than any other. So if I ask, if you had to go to your boss and say, what method should I use? It's not really obvious. ordinary least squares, the basic statistical method, and all of the other statistical methods. And in the machine learning methods, random forest, extreme gradient boosting is XGBoost is a very commonly used and very popular method, but it doesn't really work too well either on these problems. So these inclusion and exclusion errors are inherent somehow in the problem itself. And so I'm calling that a data quality problem. So we could go and test some of these assumptions that I mentioned before, like is the income equally distributed amongst household members? And it turns out we could break up the expenditure. We're trying to estimate expenditure here. We could break that up into food and non-food, and we could discover that indeed food, as slightly not expected by me, but was pretty much linear in the size of the household. So 2 people eat twice as much as 1 person and so on, but non-food expenditure isn't. So is it better to try to predict those things separately or together? Turns out it's better to predict them together. The same pattern occurs in the other districts. And then we could look at the errors and say, well, where do the errors occur? So I was very interested to determine if the errors were at the wealthy end or the poor end of the spectrum. And in fact, they're everywhere. So this is XGBoost, what we might think of as the best model. The true deciles is analysis by decile. A true decile is down the bottom. And at this pointer, this is the pointer. So the true decile is down the bottom. The predicted decile is along the y-axis. So for these two, what we want to see is 100% in all the diagonal and nothing anywhere else. And so we don't actually see that. We see lots of bubbles everywhere. So any bubble is an incorrect prediction. So you've got people in the poorest decile predicted in the 9th decile in Sambatanga, and you've got the wealthiest people, some of them predicted to be in the 5th decile. So this is a real not good. This is, I won't say a mess, but it's not very good. I don't want my machine learning method doing that. So this suggests there's some problem with the data collection. So when you look at what is the data that's collected, you go, why? No one, how do we manipulate that? What's the problem here? So by data quality, I mean, is the data collected fit for purpose? And that purpose could be a number of things. So like I said before, identifying the poor groups, could be identifying the bottom 40%, or it could be something more specific, like who gets the fuel subsidies or who gets the electricity subsidies, if that's possible. So we're looking at a range of variables. Some of them have predictive power, but most of them have very low predictive power. So there's very, very, very poor quality information. So for example, you ask people if they have a motorboat. I guess not very many people have motorboats in Jakarta. In that case, it's perhaps not very useful to predict anything. Or you ask about the roofing and the wall materials, but that doesn't tell you much about the quality of the actual house. So there are plenty of concrete houses which are almost falling apart. They're still concrete, there's not timber. So it's very hard. The machine learning or any statistical method has to work with only the data it's given. So other variables vary across different districts, as I said before. So having a boat might be useful if you live in a fishing village, but not necessarily in Jakarta. So one thing I like to do is do a decision tree. And of course, you're not meant to read this decision tree, but it also shows us that what the nature of some of this data problem is, in that, so you put all this data in a decision tree, so you've got 60 variables and all the values for all of this household samples, you run the decision tree, try to predict the divide up the sample into groups, and those groups have similar characteristics, and they therefore should have similar expenditure. Well, actually they don't. So we see very high variance in the groups that are picked out by the decision tree. So this is one of the poorer groups of people. So people who live in smaller houses, don't have lighting and so on. So so your problem here is that there's not enough data for the decision tree to make a split. So there's another problem, which is data quantity. We need more data to address that problem. So let me just make one more point about variability. So a lot of problems arise because if we just look at the data without modifying it, a lot of variability happens because of changes in circumstances over time. So natural disasters, conflicts, and so on. So that's all part of the data scientist's job, is to look at these properties and then decide whether the methods are likely to work. So predictive power of variables also varies across time. So yeah, in time gone by, you might have asked someone if they had an internet connection for their broadband. Probably not a very useful question to ask these days now that almost everyone has a mobile phone. So how to address this problem? So we've focused a lot on methodological questions in discussions with BPS and STIS. And I'm not going to go through all of those because I'm not sure we know the answers to all of those questions either. But just notice the very small sample sizes here. You've got in Brevis 1,017 sample from approximately 470,000. So the idea is to try to predict the consumption expenditure of the 470,000 households based on the 1,000 samples. So that's a very, very small sample here. And so even evaluating whether that works is a problem. So we're going to look at methods that train on 2016 to 19 data and test on 2020 data, where the task is to identify the bottom 40% of households by expenditure. So I'm going to talk about two approaches and maybe present some results. And just to destroy my punchline a little bit, the data augmentation, the use of some machine learning area level features and spatiotemporal data in a naive way doesn't work. But what we have found to work is a thing called domain adaptation. So I won't go into detail of what domain adaptation is, but to give you some indication of why that seems to work a little bit better than anything else. So it's quite common. We're not the only ones who have done this, but plenty of literature has said, let's try to look at area level features to try to augment the data for the households. So those are things like the numbers of schools, numbers of health centers, and so on. And looking at the different sorts of behaviors of the prices of different sorts of commodities and various indicators about the soil and so on and so forth. Does that actually help you? And the answer is not really. So area level features do relate to expenditure, but not very much because we're trying to distinguish amongst different households in the same area. So we're going to have to go much more deeper for these area level features to play any role at all. So that's something we intend to do in the future. This is work in progress. I should have mentioned that at the beginning. I hope to not disappoint you that we have answers to all of our questions. So data augmentation, what we want to do in recognition of the fact that we have very small sample sizes is to add more data from other districts, similar districts, to make the data set bigger. And the idea is that that decision tree will have more data to work with and hence produce a better split. And same with all the other models as well. But what is a similar household? Remember, you've got 514 of these districts. They're all different. Some are more similar than others. But if you looking at a simple way of determining whether two districts are similar and augmenting the data with all data from similar districts doesn't really work too well. That's too broad. We need to be much more fine-grained again. So looking at a range of districts does reduce the error rate slightly, but not very much. So what works better is this thing called domain adaptation, where you use some of the data from a target. So if you were trying to predict 2020 data, what we want to use is some of that 2020 data, not all of it, a small bit, which captures some properties of that data and try to reweight each instance of the training data set from 2016 to 2019 to make it look more like the 2020 data. So more particularly to make the distribution of that data more like the 2020 distribution. So not using the whole 2020 data, but just a small amount of it, about 10% of it. And this is going to address that problem that I mentioned. I didn't call it concept drift, where the distributions of wealth change from year to year. So distributions change all the time. I think I mentioned those natural resources, natural disasters problems, but also the value of the repair goes up and down, people's consumption pattern changes, rents go up and down. And as the World Bank identified about 20 years ago, people move across that poverty line in both directions very frequently near the borderline. So there's a method called domain adaptation where you try to use the existing data, but modify it to match the distribution of the 2020 data. And that's what we're doing here. So just to emphasize about the changing distribution, on the left is Brevis and on the right is Surabaya. The left is, this is training on only 2016 and testing on 2020. So the purple is the 2016 and the green is the 2020. You can see that people are getting richer in the sense of earning more, on average, more rupiah. But of course, the value of that rupiah might go up and down. So you might be earning more, but you might be worse off. In fact, that's what's happening right now in the world economy, where we're getting little pay rises, but the cost of living is going up much higher. So we're actually getting worse. And so the same can happen. And this sort of distribution shows that similarly for floor space in Surabaya, so there's the place, how people are living in slightly bigger houses, it seems there. And the source of drinking water changes. So as you get more money, you're going to do different things with that money. So one idea is, for those of you interested in economics, there's a whole field called behavioral economics, which asks the question, you know, what would you do if you had little extra money, or how would you, so in other words, to evaluate the effectiveness of those interventions. So how to do guided domain adaptation is a kind of boosted transfer learning. So this is the only thing I'm going to talk about, transfer learning. I'm just checking my time. This would be okay, right? So transfer learning means learning from one domain and putting it into another domain. But here we're learning from one data set, 2016 to 19, and transferring that to another domain, which is another data set, which is 2020. As I said, I'm trying to make that source domain. In this case, it's trying to make the source domain look a lot more like the target domain by giving you weights. So you've got to choose a little guidance set, a subset of the 2020 data. And you could do that randomly, or you could do that more cleverly. And we'll call the more clever way the selective guide. So looking at where you might need that data to be improved. So the algorithm, which we won't go through here, iteratively weights. It learns weights on the training instances so that those weights, those instances that need to contribute more to the error get down-weighted, and those that contribute less to the error get up-weighted. And when you do that, you do get to see some improvement. So here's XGBoost, the baseline we had before. So we've got to give you numbers in this talk because it's a statistics talk after all. So XGBoost error is around about 35%, as we said before, with selective guided domain adaptation. So choosing just to train on 2017 and 18 data, which are more similar to 2020 than 2019 is, and a subset of about 10% of the 2020 data, you get that error reduced to about 30%. So that's a substantial reduction in the error rate. And the same thing happens in Sambatanga and Surabaya. But I wanted to show you something interesting about Sambatanga, and that's that the inclusion and exclusion error rate goes down, but the root mean squared error, which is the actual rupiah value per household, goes up. The error goes up. So there's a kind of trade-off here between this question of, do you want to minimize your errors in predicting of households, or do you want to minimize the absolute value of the errors in the numbers? And those are different questions. And this particular method does well, or better, let's say, at improving the inclusion-exclusion error at the expense of getting the root mean squared error worse. So maybe that's good. Maybe what it's doing is getting the predictions worse for the wealthy people, which might be okay because they're not going to get any subsidies anyway. Hopefully it's not getting the errors, the root mean squared error wrong for the poor people, poorer people. So I wanted to emphasize that that's interesting to us. So I haven't seen this before, that different sorts of problems require different methods. So you can't expect there to be one method, or can't necessarily a priori expect there to be one method that will work for every possible application. So this one seems to work well if you wanted to minimize inclusion and exclusion errors. So just looking at the scatter plot here, you can see that it's with the adaptation, it's moving some of these these ones here are exclusion errors. They're the ones who are not getting the subsidy, and they're pushing them down into the area where they do get subsidy. And these ones over here, they're pushed up. So the ones here, these are the inclusion errors, they're getting pushed up. The exclusion errors getting pushed down. So it is doing the right thing with inclusion and exclusion, but it's still getting the actual prediction of values wrong. Okay. And the same thing happens in Surabaya. So our proposal for future work is to try to more cleverly select that guidance set. So if we do that, we expect those errors to improve. We also want to look at better ways of doing selecting similar districts to do for spatial regions, and better ways to look at temporal aspects as well, and combining the spatial and temporal aspects to improve this method. So we think this method is great. The question arises how to apply it in practice, and whether you could do that dynamically as you were doing the survey. So as we're doing the 2022 surveys, should we actually change our data that we're collecting along the way? And that's a question we don't know the answer to, and one we need to think a bit more about. Okay, so in conclusion of my part here, I want to emphasize that the work of the statistician is not just to deal with the numbers per se, but to look at the whole process from data collection, the quality of that data, to the end users. What do they want that data for? And is that data fit for purpose? In the original setting, I wanted to emphasize that the choice of method was not really that important. So if you say, well, is it really XGBoost? Well, it doesn't really matter. You could do anything else that wouldn't make very much difference. You're talking about a very small number of households there where the methods differ. And changing distributions over time is something you really need to pay attention to in this particular setting, and in many other settings that we've looked at too. And on a positive note, the work we're doing on the domain adaptation looks like it's going to be promising, and we want to do more of that. So thanks for all of your attention.
Okay, thank you, Professor Wayne Walker, for their presentation. For those of you, if you have any questions, just be patient. You can just keep your patient. You can just keep your question and can ask it later, because right now we will listen to the presentation of Professor Setia Pramana. Professor Setia, the time is yours.
Terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang semuanya, salam sehat kita semua. Saya hormati Pak Dr. Setiawan, Pak Wadek, kemudian juga Prof. Al-Hadi, kemudian Prof. Titin. Baru kemarin beliau ada di sini. Iya kan, kemarin saya datang gitu. Bu Dr. Sarini, Bapak Dr. Dipo, media riset, dan juga Bapak Ibu dosen yang ada. It's a great pleasure for me to be here again. UI Indonesia. Thank you very much for all the hospitality, for having us, me, Professor Wayne, also Doctor of Candidate Bu Siti. Amin. Actually, Bu Siti, our team in BPS also for big data. So have a pleasure to be supervised by Prof. Wayne. If Prof. Wayne have discussed many things about the PMT, proximity test, which actually will be useful. These numbers actually will be very useful for government Indonesia, right? To make sure that who will be considered as poverty or not, poor or not. So what you see, actually, what you observe in the previous presentation is actually is one very good example of my presentation, the machine learning or AI for official statistics, because the one that have been presented is one example how machine learning is being used for making sure that the official statistic produced by a National Statistics Office is very good and high accuracy and good quality. Otherwise, you will be okay. Why our colleague or my friend or my neighbor, yeah, they are poor, but you can get any like help from the government, right? Because this also needs some statistical method for predicting the poor or not, the condition of the household. Can I see my presentations? Yes. Because you are standing there, so I just need to follow you. Okay. So I will just briefly, what's that? Maybe this one is better. Okay. I will just briefly give overview of what AI can be done for official statistics. This is actually one of not my field, but the field that been used. I know Pak Hadi is focused on the bioinformatics, so I'm a bit in that way. Bu Sari ini, Bu Titin in health and etc. So this is kind of maybe application of artificial intelligence. Maybe it's not that common for university, for us UI, for example, because it's it's commonly used for like BPS in the Statistics Indonesia. But this actually example of how the AI can be used for public goods, because once the official statistics is being used and then being collected and also being produced, it affect the government, it affect also the citizen, the people. So what is official statistics? So I will just briefly maybe overview based on UNSCE and also Eurostat the definition of official statistic. Actually, just brief definition is statistic produced and disseminated by national statistical system, and then this including the national ministries, aligned ministries, organizations, and also international organizations. And usually it's collaboration between several line ministries to collect, process, and also to disseminate the statistic on behalf of national government. For example, BPS Statistik Indonesia. Ada yang tahu? I'll just mix up between bahasa Indonesia. Anybody knows about the inflation? Ada yang inflasi, tahu inflasi nggak? Nah, nggak penting ya inflasi ya? Penting nggak kira-kira inflasi? Buat apa? Inflation will be used for anything because inflation is showing how is the price going up, is going down. This actually penting buat nanti kalau 2024 sebenarnya atau growth gitu ya buat politics. Anyway, means that government inflations, right, and also growth economics. That's showing how the situation of countries. You are the students, you should know about that. And also kalau nanti kalian kerja if you works, inflation is actually like part of whether your salary goes up or goes down, because that's showing the needs of the goods. If the price is increased, so you expect to have also the salaries will increase. That's one way. So that's example of statistic produced by NSOs. And so this actually official statistic serve as a basis of decisions, and also for I mentioned politicians, policymakers, and also societies for reliable policy making. Okay. When we mention statistics, especially official statistics, we cannot just, okay, this is the statistics. Like if you are in the business, you can produce, okay, this is the number of clients, the number of participants, etc. Or this is the how many applications or how many books have been sold, for example, for a couple of months, for example. But then for official statistics, there are some principles need to be follow. For example, relevance and impartiality, equal access. Anybody can access that. So, Bapak Ibu, yeah, if you need the data from BPS, usually you can go directly to BPS Statistik Indonesia, or you can contact the office in BPS, or you can go to websites. And also, they are standard on that. Transparency. I just mentioned with Bu Sarini that We try to use big data right now for official statistics. For accountability and transparency, I ask all academia to review the methodology that we use. The review means that we show the techniques, we show all the technique that we use either for data collections or either for methodologies, and then you can make sure that the data, also the methodology is good and as expected. So anybody, and also the academia can give us a feedback to improve the quality of the statistics. And also source official statistics should be also sustained. You cannot just basically based on one source, maybe a couple of days or months or years, it's gone. You should be sustainably of the sources. Confidentiality, there's also things. You have now PDP, perlindungan data pribadi, right? Confidentiality. Ada yang mau datanya nanti ketahuan? Enggak ada yang tahu. Tapi kalian di Facebook yes aja kan? Boleh, tahu-tahu, ya kan? Confidentiality is one important. You never seen that National Statistics Office will produce, okay, you are your data is that. Who is a poor, who is not poor, for example. The National Statistics Office just give like aggregate data. Otherwise, it's against the law. Nanti ada Reksosek, Bapak Ibu. Ada yang udah didatangi kemarin, ada registrasi sosial ekonomi, Reksosek. That's quite different with the other one, because that's actually, we try to find a household that have in lower than poverty level, and then we try to give the individual information to government. That's why the regulation, there are some changes of regulation only for that type of data. And legislations, national coordinations, and also we have international standards, also international cooperations. Okay. Okay. So there are several types of statistics. BPS, this also needs to be clarified because, okay, data semua di BPS. No. Ya Bu Siti ya, we have to make sure this one, right? The basic statistic or statistik umum is actually the responsibility of BPS Statistik Indonesia. Other type of statistic, like such as sectoral statistic, is produced by ministries, produced by universities, for example, produced by other institutions. That's sectoral. Like, for example, data of COVID. Nggak ada data di BPS COVID ada berapa, pasien ada berapa, right? That's at the Ministry of Health. 2 days ago, we have a discussion with the Ministry of Health about that, how they use digital for that. And also specific statistic, and they have like, you have research that basic specific statistics or related to example of some case bioinformatics, right? That's a specific statistic. It's not owned by, it's not responsible of BPS Statistik Indonesia. And these are several press releases of official statistics. Okay, monthly you have inflations, export, import, tourism, and also quarterly we have growth, and also business tendency, customer semester we have poverty. Kemiskinan itu setiap setahun 2 kali, ya. Padahal Bapak Ibu semua, Presiden inginnya, our President every month we should have, right? Imagine we have 270 people in Indonesia, and you have to know which one is poor, which one you need the help, and etc. Yeah, that's the next one. We have annually Human Development Index showing how developed one areas. And all the data come from the BPS offices throughout Indonesia. So you have most of you are students of mathematics and statistics. You get that. Saya mau nanya deh. Anybody knows how to get the data selain datang pergi ke BPS atau gimana? Anybody? Apa yang harus dilakukan dengan data? Data collections? Ayo dong, sekalian kuliah nih. Saya biasanya nanya satu-satu, Bu, maju satu-satu gitu kan. I'm lecturer also, so just why just. Ayo, anybody can answer? Lakukan apa biasanya? Survei? Sensus? Ada lagi? You can have a census, you can have survey, that's basic of data collection, administrative product, Also, based on we have digital data we have other ways, other means according to development of science and technology based on the undang-undang statistik. Yeah, means that we can have the data not only based on the survey or census or some database register, let's say from Dukcapil of UG or from data sistem informasi kependidikan, ada Ibu ya, kalau di UI apa namanya, sistem kemahasiswaan, ya kan? But we can get also the data from digital technologies, right? And this actually, my talk will discuss how to utilize that type of data for providing all the statistics I mentioned before, so to make it as good as possible, as soon as possible, as good as possible as well, and also to provide it in more granular. Ada yang paling jauh nggak? Ada yang tinggalnya di sini paling jauh dari Jakarta? Ayo dong. Aslinya tinggal bukan di sini. Tahu paling Pocin semua, ya kan? Gimana? Ada yang jauh? Papua. Sulawesi. Ayo. Cengkareng. Ada yang Cengkareng ya? Asli Cengkareng? Nggak ada. Ini orang Depok semua. Kalimantan. Ah, dari mana? Kalimantan Barat. Dari kotanya? Oh, Sambas. How many tahu berapa population di sana? Kabupaten berarti kan ya? Ya, kabupaten. 200.000. Ada berapa orang yang miskin di sana? Wait. Do you think that's important, right? Kalau buat beliau nanti kamu kan, number of dari 200.000, how many are below poverty line? Ya, nggak tahu, ya, sulit. Kalau di kecamatan tahu nggak kira-kira? Kecamatan apa? Kecamatan apa di sana? Sembaro. Ada berapa orang yang miskin di sana? Persen? 40%. Waduh, baik banget tuh. Bukan data BPS ya. BPS bahaya datanya. Oke. Perhatikan, image kalau BPS hanya punya saat ini number of poverty level on kabupaten kota regions. Kira-kira kalau kalian jadi presiden, bukan tahun 2024 lah, nggak ada yang 2024 di sini, kan nggak ada yang rambutnya putih sebenarnya. Kira-kira butuhnya sampai ke level apa statistiknya? Butuhnya level apa? Kalau bisa kecamatan, kalau bisa desa, right? You going in more detail. Right now, official statistic can only goes on to, let's say, some level, province level or region level or municipals. Dan juga gini, tadi presiden, people want to have data on more on up to date. Kemiskinan kita mungkin setiap bulan apa Bu Siti? Datanya itu Maret and September. Bulan Desember gimana? Ya belum ada studinya. Kenapa? No, kita tidak melakukan survei. Imagine if we do survey every month. That's challenging. So that's why to produce different type of data and also produce statistics that can go in more detail, granular. So you have more granular on time. So every month, yeah, every day, something, right? So we BPS have initiative to do several. Maybe we mentioned the alternative data sources for developing official statistics. These are several cases. Actually, these are several cases, and I discussed with Bu Sarini, Bu Titin, and if you want to, anybody interested in analyzing this data, I'm very interested to join the research with that. So we have data for marketplace. Actually, most of them are Bu Siti is the one who did that in the beginning. So we just do that. So we have a flat tracking. So right now we collect the data of flight in Indonesia every day. Yes, from one city to another city. Job vacancy site. Ya Bu Siti ya, Pak Lukman dulu nih buat juga online booking sites, and then online booking sites This example, just example. Like last month, Pak Jokowi minta ke BPS, tolong dong harga hotel sebulan terakhir. BPS belum melakukan survei, Bu. Ya kami pakai datanya nih. Kita ngambil data every day, kita ambil, kita pakai sebagai proxy. Of course, there are some proxy. It's not actually the data, the price of in online sama di lapangan beda kan? Kalau kalian beli di GoFood lebih murah GoFood atau lebih murah di sini? Antara data harga GoFood sama harga di restoran lebih murah mana? Restoran, ya kan? Tapi paling tidak fluktuatifnya kan nggak beda kalau di sana turun, turun dan sebagainya. Itu yang bedanya, ada ongkos dan sebagainya. We have digital price, ya. So online news, so we just discuss how to capture the information from online, who says that, and so that can be used for several statistics. We have, I will discuss more on satellite imagery. You have satellite images, and then it's from satellite, of course, and it's more or less like DNA sequencing, DNA microarray, Pak. Kebetulan saya belajar microarray sedikit ya, jadi kan mirip lah. You get the capture of nighttime lights. Jadi kalau malam itu kan kelihatan dari atas tuh gelap, terang. Kalau DNA juga sama sebenarnya, itu nanti mirip lah. Iya sama. The good thing is mathematics you can use the same method for different applications actually. Yeah, ekspresinya exactly. So you have gene express, Bu, in DNA. We have also nighttime lights. So this area, if gene expressions is like say a lot of intensity, that means that is having related to some expressions. For us, this not gene, but this is like regions. It could be desa, village, and etc. And then saying that, okay, during the night, this area showing activities means that the poverty is low. I'm not saying that no, but low. Academic activities are so high. So that can be used for different type of statistic as well. Also during the night, the day, we can see also different type of images there. And also mobile positioning data, MPD. Anybody without handphone? No, right? Kalian punya dua lah, ya kan? Satu atau dua? Satu. Masa satu? Dua lah ya. Okay, this example of one data indicator, I will just skip that. This is, so the idea is like this. Why, maybe you ask, where is the machine learning? Ada yang tahu datanya, gini deh, saya nanya deh. Ini tingkat 3 ya, Bu ya? Ada yang sudah analisis datanya berapa baris? Paling besar? Hah? Oh, semester 1. Ya, semester 1 baru. Paling besar? Paling UJT itu paling sedikit kalau di buku itu kan. We have a data sets of millions rows and also columns. Jadi learningnya di sana nanti. Jadi different, and then also images nanti computer vision masuknya di sana. This example of big data infrastructure or BPS. Again, if anybody wants to join about in more detail how we do with data, also big data, it's also very welcome. We have different data sources, administrative data, survey, web, also spatial data. We try to combine that. So this example of mobile positioning data, just example. And also this is the result. The result of actually one of machine learning technique that developed by our team, by BPS team, not my team, but our team. Look, your phone will report your locations. Depends. We have passive GPS, also active GPS. Me and Bu Siti once develop. Oh, I will have that example as well. Oh no. We have example that passive. Kita tuh berapa ya? 30 seconds or let's say every 1 minute we can track whenever you are. Jadi nggak pernah bohong. Jadi kalau lihat dulu Pak Hadi ya, kita selalu waktu kecil tangan dikunci ya, mulut dikunci, yang ngomong tangan, yang ngomong handphone sekarang, ya kan? Pak Haldi kemana, ngakunya kemana, tapi bisa kemana kan? Handphone nggak bisa bicara. So your position right now is being tracked by your the mobile network operators, and this being used by the government, not to track you, of course, but to see mobilities. How many people in this area during one period, and how many people move from one region to another regions? It's not easy actually. It's not easy task because every you have millions and millions of that data, and then you have to do some algorithm to have this type of graph. This is easy graph, but actually not easy to produce. People from Malaysia go to, for example, Danau Toba in one area. Yeah, this also right is from Timor Leste. Ada yang pernah ke Timor Leste? Belum ya? Timor, NTT. Udah ke Timor ya Bu ya. NTT, Labuan Bajo. How many people from Labuan Bajo to from Timor Leste to NTT to Labuan Bajo? So we have to there are some calculation on that. This example, Bu Siti juga ikut juga nih. Remember Bandung? Yeah, metropolitan statistical area. This is Bandung. Actually, we have a moving image for this. Ini Bandung, city, but you can go from one another one. So this is like dots. How many people around this area, and then from where from one region to another regions. So ini ada videonya. So you have video. I can just skip that. So one example is also we do also with text analysis. Anybody interested in text analysis? Belum? Ada tertarik dengan analisis teks NLP? Nah, ahlinya Bu Siti juga nih. Beliau ahli semua. NLP bicara dengan teks. Data kan tidak hanya berupa ini ya, angka ya, tapi berupa teks. Nah, teks if you write down informations, right, from the websites, we try to read that and to standard that based on some coding. This is example of name entity recognitions from web, from media, from news. We extract what people talking in this topic, in this news. Behavior tracking, this also by Bu Siti. Jadi dari one point to another point. This is 2 years project. Right now, and also right now we try to use these satellite images, as I mentioned, satellite images, which can see the infrastructures or urban footprints, agricultural areas, and also we try to combine into several data sets, social media. I think Prof. Wayne has mentioned about the information about the pollutions and NDVI and etc. With next year we try to combine with mobile data. Bu, yang nanti Pak Taufik review itu belum ada mobile data, Bu. Next year will be use mobile data for that. That's not been produced, not been combined right now. So I skip that. I just skip that. Okay, this is just example of the data that wait. Okay. This is just recently by our students. Ini S1, student S1, tapi baru produce Q1, Pak. Jadi kita profesor kalah ini. Q1 ini. Kemudian saya dengan Ari, ini multi-source satellite imagery for point of interest for poverty mapping. We have data from different, only from satellite, you can have different type of data, and you have to combine that, of course, into information, and then combine with deep learning, several methods on that. And then we can have this plot of information about the area with the red is the area that have higher poverty level. Madura, ada orang Madura nggak? Nah, Madura. Oh iya, itu higher poverty level. Yes. So this and etc. And so we combine into, we can have also which area we combine with satellite images, not only nighttime light, but so we can combine with different type of data sets. But not yet using mobile phone. We try to combine mobile phone. That's going to be very difficult because the mobile phone as well needs different type of analysis. Okay, this example of some information that we use, mobile phone and also satellite images, web scraping, text analysis, and also other machine learning process. This initiative is this one also to change. Before, if we use census survey, maybe we have to combine different type of data. Before we have population sampling, we do sampling. Maybe next time we will use statistics modeling as shown by Prof. Wayne, machine learning as well there. Also, before we focus on statistical process, survey management, and then we focus on the statistical product design, and also to try to datafication all the informations. I think this is example of this is some of our publications related to big data. You can download for free to understand how geospatial data, how to do the satellite images analysis, how to model the data of satellite images for poverty mapping, also other examples. So the problem, the challenge is the data acquisition. The data comes from different platforms. It's not easy for you to for us to capture. Statistical methodology also still being developed. It's not mature. There is a lot of room for improvement. Also, the quality of the data. Sometimes the quality. I think this is the issue that you mentioned, right? The quality of the data. Yeah. Quality of data begini. Ada yang udah didatangin Resosek gak kemarin? Yang tidak didatangin siapa? Nih saya harus dicek juga nih Bu Titin kayak kemarin. Resosek enggak ya orang tuanya? Ada survei. Regenerasi sosial ekonomi. Ada mungkin sebagian, ada yang tidak. Itu pertanyaan juga. Ada yang pakai proxy. Ya itu di lapangan. It doesn't mean that BPS itself, but because BPS using like partner, mitra, so maybe the quality of the data that they collected also is not good. That's why it is also challenges. Also the privacy and data protection as well. Also we need some regulations on national system for that. I think that's all for my presentations. I know it's maybe biasanya 2 jam Bu soalnya Bu, 3 SKS itu kan. Tapi I try to condense on the several minutes, and maybe I'm looking forward for discussion from all these bright students, also very bright lecturers from UI. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you, Professor Setia, for such a very interesting presentation. And now we are moving on to the next agenda, that is discussion session. So first, I'd like to give for the chance for 3 participants who wants to ask questions. Anyone? Just raise your hands. Ada yang mau tanya enggak, atau enggak harus nanya juga sih, mungkin mau komen atau usul apa aja lah gitu. Oke. Nanyanya enggak harus, maksudnya tadi kalau wow, kalau gitu saya aja. Kata Prof. Setia, pertanyaan terbagus dikasih buku. Ayo. Ntar dengan tanda tangan ya Prof ya? Oh, oke. Iya. Oke, tanda tangannya dulu deh. Oke, silakan. Siapa? Ada. Sebut nama, angkatan, terus pertanyaannya ditujukan ke siapa gitu.
Okay. Good afternoon, Professor Wayne and Professor Setia. So, let me introduce myself. My name is James. I am a statistics student, undergraduate statistics in the year 2020. So my question is, forgive me if it's irrelevant to what you showed during the seminar, but I would like to ask a few general questions regarding the data scientist world. So the first question is, what is the most effective and efficient way to improve yourself, your skill set in becoming a data scientist? That's the first question. Boleh dua kan ya? Okay. And the second question
You have
is,
done a computer science
and the
degree?
second question is, based on my observation, correct me if I'm wrong, but I feel like whenever I compare the developing countries in Southeast Asia, such as Indonesia, and I compare them to Western countries like USA, Canada, and other countries, I feel like data scientists, this skill set of being a data scientist is not as appreciated here in the developing countries, such as in the developed countries. I'm not sure if that's correct, but based on my observation and research, it says that so. So my question is, do you agree with my statement? And if so, what is the correct path in order to make becoming a data scientist a more valuable skill set than it is currently right now in developing countries? Thank you.
So there were three questions. I'm not sure if I remember all three of them, but the first one was about skill set. So how do you be a better data scientist? So that's why I emphasized in my talk the practice. So I was giving you an example of how to do data science. I'm glad you asked that question. So, don't assume anything. The word data apparently means given, but don't assume the data is given. There's a lot more freedom and a lot more flexibility than just getting your computing skills right. But if you want to get the computing skills right, there's no substitute for actually trying to analyze the data. Setting yourself a little hypothesis. So data science is meant to be scientific. It's a scientific method. It's proposing hypotheses. It's evaluating them. It's asking questions and rigorously using that methodology to prove yourself right or wrong. And I'm right some of the time, and I'm wrong a lot of the time. It's just that rigorous process that you have to understand, I think. And that's what I think would be valuable for someone working in the area. So look, lots of our students can do Python, and some of the other ones can do R. And it doesn't really matter that much. We want something more creative and a bit more analytical from our students. As to your question about qualifications and differences between recognition of qualifications, I think that was the question. We have a rigorous process, so I can already point to City Maria, who's very well regarded in our school as her undergraduate degree is exemplary. So when we come to evaluate PhD students, we always look at the work that's been done and the range of abilities and try to find a fit for each student to each particular project. And I should think that any employer would do the same. So if you want to work for Facebook, fine, do what they want to do. If you want to work at university, then we're looking for research skills and creativity and innovation and a lot of technical background. What was the third question? Was that all of the questions or did I miss one?
Yeah.
Tingkat berapa sekarang? Tingkat 3. Oh, masih panjang. Skill set, theoretically, and also you already in a very good university. It's very good. But you need to have exposure from outside the universities. You have to go. Let's say, I know all the lecturers of UE, they have other projects outside. Try to go with them with the real data, not book data. I mean, toy data I mentioned, data that's from the book. Yeah. You learn that theoretically, yes. I'm not saying that you don't have to learn from the book. You should learn, but you should have to have that also that from communities, from the project from outside the universities. Makanya mereka belajar kan Bu ya sekarang magang, should go for internship or that. Those things. Whether it's appreciated or not, now statistics been very appreciated actually. You know the salary berapa Ibu? Kemarin ada mau pindah tuh ya 15 lah, 15 juta. Belum appreciated sih ya, no. But tingkat manajer itu udah angka 3 digit di atas 100. Ada di ini. Nggak usah disebutin lah namanya gitu. Tapi jangan nomor itu. Ya. Tapi tadi dari mana mereka? Dia project based. Tapi penting adalah you learn basically. Karena masalah kadang-kadang gini. Sometimes you do all the projects outside and then you just learn computer science without knowing statistics. That's dangerous things. You do, okay, cluster analysis simple, I mentioned. And then actually the cluster, the data is not numeric, it is just categorical. You just blindly use the advanced statistic methods, but without knowing the basic, that's also dangerous. So you have, you are in the very good university right now. Expand your view by adding discussion with the communities, also coming to this type of workshops. Yep, Wayne, like you have learned from Professor Wayne is also, you know, it's very lucky you because Professor just come here and then in front of you, you need to go there. You can get directly information, also knowledge from him. That's one way of gaining the information. Yeah.
Okay, thank you, Professor Wayne and Professor Setia for the answers. If I may add, just karena sebagai dosen aja gini ya, from the internal as your lecturer, I think that one way also to achieve your aim is that like attending events like this, you know, because just for myself, looking at the presentation from Professor Wayne and Professor Setia, I was just wow, gitu ya. There are lots of cool things that they've done over there. So I mean that, okay, we think that we've learned a lot. We think that we know a lot, but then maybe it's just inside our small circle, but then just go out, attend, you know, every now and then events like this, you see this really amazing, the works that they do over there before, then you'll see, oh my gosh, there are lots of things that I need to learn. And then you think that, oh yeah, I have, you know, I'm in a good university, I learned such and such and such. That's not enough. So like Professor Setiabi said before, oh, there Merdeka Belajar, you can access so many things. If you really want to equip yourself with the skills that you want to, what is it to build when you want to be a data scientist? Yeah, probably, yeah, that's why we have events like this. And like Professor Setia said before, we are very lucky to attend the event today. Yeah. Okay. Thank you, James, for the question. I think that tadi Prof Setia bilang kan mau ngasih buku, nanti saya juga ngasih buku ke James, nanti ke ruangan saya. Okay, next. Any other questions? Ada yang mau tanya lagi? Ayo, kalau yang nanya dikasih buku deh, bener. Wah, ini sih jadi nembak ya, Prof. Oke, silakan.
Check. Hello. Okay. Good afternoon. My name is Naufal Farid Mohammed. I'm currently studying statistics batch 2020, and I want to ask about in real life. Of course, it's hard to find a good quality data. We often find a dirty data. So I want to ask Professor Wayne and Professor Setia, and how can you manage this dirty data and process it into a good quality data? Because in my experience from lecture, if you have in case, just like case, a missing value, you just have to input it, or maybe you just have to remove it, and etc. So I just want to know about it. In real life, how can you process this dirty data into a good quality data to analyze? And how long does it take to process the data? I think that's all. Thank you very much.
Yeah. Okay. Well, that's a very good question. And generally, if you ask that question, everyone will tell you that 80% of the time is cleaning the data and 20% of the time is plugging into the methods. So data cleansing is part of what I didn't call it that, but that's part of that pre-processing that we always do. In the case of the survey data, it's actually quite good in the sense that it's complete. There are no missing values and so on. But in many, many applications, particularly social media, text data type applications, there's a real need to clean the data by, even simple things, removing hashtags or keeping them if you want. But it's a long and complicated process, and there's no one right answer to that question. So at the beginning of our project, we actually were going to write a paper on this point. And so we looked at one of the examples from Pulse Lab Jakarta and tried to work out exactly how they pre-process their text data. And we couldn't really work it out, but at the beginning, they had half the amount of data that they had at the beginning. So there was a substantial change in the problem that they were investigating by that data cleansing. And so there was no way of knowing that the data cleansing had not changed that problem in a fundamental fashion. And so the next thing we did was go and look at the standard textbooks on data mining. And because we're collaborating with law, so they said to me, well, what do you teach them in class? What's the textbook say? But if you go to the standard machine learning textbook and data mining textbook, what do you think they say? They say absolutely nothing. They tell you nothing at all about cleaning the data because they assume that the data is clean when you've got it. And so what we try to encourage in data science is that when you're dealing with raw data, as Katya mentioned many times, the raw data is not really suitable for applicability to these methods. So you've either got to change the data, change your methods, but mostly the methods rely upon the same good quality data. So it's totally unsatisfactory. It's part of the actual 80% of the work, and there's no real good guidance out there and nothing in the textbook. So it's really you have to just make sure that you document it and you know what you're doing, and try to make sure that you're not changing the problem when you do that cleansing. It's a really serious point.
Okay, thank you. Yes, I think everything has been mentioned by Wayne, that there's no single ways. Again, 80%. 80% of the works actually data cleansing. That's the thing that I think we, Bu Sarine, Prof. Titin, we have to teach the student as well, because when they see the book, they think that this is the data they will get during the work, but actually it is not the case. Forget about. Actually, I have a very good illustrations. You can implement all the AI good things, but if your data cleansing is not good, and so there are some biases now, the filterings, and then it will also lose all your AI. So for example, like this. This is what example that I face. There is a data missing data. I discussed with the just newly graduate from university, and then they I have missing data, and then they implement this type of advanced missing data. Very advanced. And then I said, why this data is missing? Nggak ngerti, don't know why data missing. And the data is about the every cellular. Usually they have the information of how many gigabyte of this person spent for a day. And it's missing from several numbers. They don't care about that, but they just want to impute that with the missing data and etc. Right? And then when I check the gadgets, actually it's 2G. Artinya apa? Nggak ada without no data. So if you input, that's going to be very dangerous, right? So first is understanding how the data is being collected. That's the most important. Itu paling sering dilupakan oleh mahasiswa. Dia pikir datanya udah jadi, udah gitu. You have to know how the data is being collected. Me, myself, basically I'm bioinformaticians. Pak Ahladi also. I have to learn how the cell biology, how about the central dogma, ya Pak ya? The data from transcriptomics and also transcript, etc. How the data of microarray is being produced. Tadi Pak Haldi bilang ya, kalau kita nggak ngerti, atau saya ngomong Pak Budiawan tadi kan waktu di Karolinska ya Pak. Jadi ada masalah biologically, jadi kalau biologically masalah how data collected, itu akan masalah ke datanya. Nah, understanding the data being collected one way. The second one, of course, you have to see the unusual pattern, etc. One case, Kalau datanya data text, as you mentioned with Wayne, text is that's horrible. Text pernah dengar kalau di Tokopedia itu kan kita nggak boleh jualan barang-barang tertentu, ya kan? Kalau kita mau cari paracetamol boleh, paracetamol, oke, search bisa dapat paracetamol. Tapi yang jahat dia nggak begitu, kan orang Indonesia kan cerdas. We are very smart, but in different way. For example, paracetamol, they put not, kalau kita search paracetamol nggak dapat, tapi ada apa? Mereka nulisnya P, 4, R, A, nggak dapat kan? Nah, itu kan, padahal itu barangnya nggak boleh dijual. Banyak barang-barang yang dijual di situ. So they change. So it's also we have to learn behavior of how data been collected gitu. Behaviornya. Oh kalau begini nih berarti error gitu kan. Kalau ada hashtag misalkan tentu error. Ini yang harus dilakukan. Jadi behavior. Jadi as I just give some example as mentioned by Prof. Wayne that there's no single rule for that. But yeah, first understanding the data and also behavior how they're being collected. That's one first thing you have to do to understand the data collected, the sense of the data. That's also sometimes the students doesn't really have a sense of data, but that sense of data also built not only 1 or 2 years, but through times. Saya juga butuh waktu S1 nih data apa gitu. Tapi once you are dealing with data, you have built sense that. Just like Spider-Man sense, right? Spidey sense, you have sense of data. Berarti nggak suka nonton film Spider-Man ya kelihatannya.
Thank you for the answer. Is it is it answering your questions? Okay, thank you. Next. Okay, silakan.
Okay. Thank you so much, Bu Sarini. Before that, I want to say a very, very sorry because my English is not good enough. Okay, my name is Tafa and I'm from Actuarial Science 2021. I have a case study with the data. Once you open a time, I saw the football pundit. Okay, this is still the World Cup momentum, okay? Okay. He said that not all of in the football can be explained on by the data. For example, the ball possession or shoots on target, etc. Okay. In general form, my question is, how does statistics can handle this problem? While not all of any things in the world can be explained by data. Thank you.
If I may clarify, the question is that there's something, not everything in the world can be explained by data. Is it something like that? Then you give the example for it, like in football. Okay, so you want to know what's your comment on that? Because usually statisticians say that everything should be explained by data, but he can find something that, no, your data cannot say anything. What's your comment on that?
Well, if you want me to predict the winner of the World Cup, I'm not going to do that. And anyone who thinks they can predict the stock market is lying, and that includes the crypto markets as well. Look, yeah, not everything's predictable, but our job is to find the things that are predictable. And data science, I think, is interesting because, you know, we don't have to be like those physicists and work on big machines. We can invent our own sorts of problems. And part of the trick is to work out what, the notion of causality. So when we look at these, when I look at the statistic, the survey data from Susanas, I'm always interested in, why is that the case? And I'm always looking for explanations because that can help me understand the data. So, why is owning a boat a good thing to ask? And why is it the case that you can't always predict food and non-food separately? There's a good answer, but it's not an easy one. So yeah, there are lots of things I think are predictable. So putting it in a positive light, those are the things we're interested in studying. And I do like to distinguish between correlation and causation, as everybody does, but I would like to look for those to try to think about causal factors as well, as in relationship to explanation. So there's a lot of correlations in this data, and some of them are causal and some of them are not. And it's good to, as part of our understanding of data, to understand that difference and to use that to improve the whole process. So we've got quite a lot of flexibility in the data collection, in the data analysis, and in the process itself, and in explaining what the significance is. So I think that's one thing we didn't quite emphasize enough, which is the explanations that the data provides that we then need to convey to policymakers, decision makers, that derive from our understanding of the data. So it's sort of explanation arising from the data, but not necessarily using the data directly. So there's lots and lots of interesting and fundamental questions there. So I'm focusing on the positive side and not just worrying that there's lots of things that we can't understand. I'm sure there'll always be lots of things that we can't understand.
Oke. Ini persepsi saya. Mathematics I love mathematics in terms of, because mathematics try to understand the universe just in general, right? A phenomena, yeah. And then you have phenomena and it's captured by data. You try to find regularities by having, like, you put some models on that. All the models are wrong, but some are useful. But you try to have models, and the model, from the model you try to predict, let's say. But not everybody can be predicted. Why? Because there are some limitation of the model that we, or mathematical expression that we have. So, you know that in some case, you have y, you try to predict the y, you have data, and then you have some x's, but of course you have some error, right? It's unknown information that maybe not always can be predicted, but some things that cannot be predicted. And then you mentioned that nothing's tidak punya data gitu. Nah, tidak semuanya ada datanya gitu tadi, maksudnya gitu ya. Tidak bisa dijelaskan, maybe it's not yet now. Saya bilang karena semua bisa sebenarnya, mungkin ya, maybe. Dulu orang mana tahu ada DNA expressions. Sekarang with technology you can get the DNA expression, ini expressions, you can have DNA, right? Sanger sequencing itu tahun 77 kalau nggak salah itu dibuatnya ininya. Itu bagaimana DNA dulu nggak tahu kita DNA. Maybe right now we don't know some things because that cannot be datafied gitu. But maybe they are in the future. Maybe there will be some technology to have data of that. From face you can understand now how the happiness from the face, right? Kalau sekarang kan bisa mukanya nih lagi senyum, lagi ini, dulu mana dia lihat aja. So right, yeah, we are limited with technology right now, but once you have the data that can be also used for some information, ya, itu mungkin karena mungkin sekarang masih terbatas saja. Pak Haladi ini data DNA diambil, protein itu dia. Dulu mana? Kapan ya Pak data protein ya Pak itu ya? Data DNA itu mulai kapan ya Pak Aldi ya? Mulai ada tahun 1900 belum kan? Belum ada. Nobody knows about how the DNA works, but now we can understand because we can get the technology to produce data. Gitu.
Okay, thank you, Prof. Wayne and Prof. Setia. Oh, yeah, Pak Hadi. Okay, I think because the time is already 3 o'clock and we know that our speakers are very busy, so I just stop the discussion. I mean that the questions from the audience, but for Pak Hadi, or kalau the other lecturers want to ask question or comment, please have a go.
Oke, terima kasih ya. Ini sangat memotivasi kita ya. Challenging-nya ternyata luar biasa ya di Indonesia ya tadi masalah official statistik gitu ya. Tapi ini tadi saya diskusi juga dengan Pak Budiawan karena tadi salah satu terobosnya kita mengembangkan big data ya sendiri. Nah,
Pertanyaannya, big data yang dikembangkan ini apakah officially di-recognize oleh pemerintah kita atau memang bagian dari project aja dari PPS gitu. Kalau officially, apakah kita bisa nanti bisa terlibat di situ? Dan ini ada satu challenging sebenarnya. Kebetulan Pak Budayawan kan beliau ahli toksikologi ya.
Ya.
Dan sekarang kan perkembangan pestisida itu di Indonesia itu dari dulu sampai sekarang tuh nggak pernah dipetakan gitu. Pestisida. Jadi sebenarnya kita tiap hari itu minum makan racun sebenarnya tiap hari. Nah, itu sebenarnya harus menjadi concern juga. Apakah pernah kepikiran nggak tuh sama BPS gitu. Karena ini apalagi sekarang kayak tadi ya masalah zat-zat berbahaya tadi. Sekarang kan banyak sekali beredar tuh di Shopee gitu, mohon maaf ya. Katanya orang bisa beli gitu. Nah, dan itu sangat sebenarnya harus di-trace kan, seperti itu. Nah, challenging-nya apakah bisa nih pihak-pihak lain nanti terlibat di sini atau bisa memanfaatkan ini untuk mungkin untuk spesial purpose mereka gitu. Nah, mungkin Pak Budayawan bisa nambahkan Pak Budayawan.
Dari satelit.
Yeah. Excuse me, I will just speak in bahasa proper. Because we have a big problem about this. Yeah, I mean it's about chemical distribution as hazardous chemical, right? You know, it's hazardous chemical, yeah, chemical. So I need Indonesia is not clear between the. I mean it's based on the regulation because there is sectoral. So there's sometimes for distribution chemical is so easy here in Indonesia. Actually, this chemical is very hard for us, but the people stock so easy to take the substance, yeah, from the online sharing and online they can take it without the screening, without what permission, something like that. So that's why how about the big data? We can take this distribution both chemical like pesticide also. I don't know exactly based on this, your experience in this case. Thank you very much, especially in statistic data. Okay. Thank you.
So I think that's. Thank you, Pak. Let me just respond it in bahasa, right? Sorry, Wayne. Jadi pertama Pak, ini data belum official. Artinya gini, belum jadi statistik official, Makanya itu PR buat kami. Kita 2000 panjang loh perjalanannya Bu Siti ya. 2014 saya pulang, 2015 kita mulai untuk menjadi official tidak prinsipal yang pertama. Kemudian kalau yang MPD sudah, mobile positioning sudah jadi official data. Jadi mobilitas antar itu sudah official. Untuk yang tourism statistik sudah. Datanya bagaimana bisa diakses? Datanya itu kalau mobile positioning data itu kita harus kontak dengan Telkomsel, Indosat. Jadi kita pun nggak mendapat data full, kita dapat sampel tapi di dalam sana. Kita nggak bisa share karena ada NDA-nya, karena itu terkait sama ini. Kalau data citra satelit itu kita kerjasama dengan BRIN, dengan LAPAN. Yang high resolution, kalau yang low resolution bisa ambil aja free Pak. Cara yang ambil ada di buku yang tadi. Kemudian pernah nggak untuk yang isu-isu? Yang pertama untuk kita begini. Untuk BPS sendiri tidak sampai tadi, itu kan udah sektoral maksudnya. Sektoral. Jadi kalau sektoral itu bukan jadi bagian dari kerjaan BPS gitu ya. Tapi kalau riset, nah tadi saya bedakan Mbak. Ada riset, kami lakukan riset juga. Di STIS itu riset kemarin kebakaran hutan dari Citra diambil. Pollution kita ambil juga. Itu sebenarnya nanti ujungnya nanti ke statistik SDGs terkait statistik lingkungan sebenarnya. Statistik lingkungan kita itu SDGs terkait lingkungan goal kita itu statistiknya belum banyak bagus sehingga kita mencoba pakai statistik lingkungan pakai itu. Kalau nanti ada isunya yang tadi terkait dengan toxicity itu mungkin nanti saya coba kita diskusi ya Pak. Kita bisa follow up.
Ada masalah begini Pak. Kita tahu nggak berapa pestisida yang beredar di Indonesia?
Nah, itu
kita tahu nggak? Yang kasus kemarin itu arsenik yang kemudian orang bisa semudah itu meracuni, mati satu keluarga itu.
Oh.
Terus data itu dari mana dan kemudian sebenarnya haknya siapa yang punya data itu? Nah, persoalan kita nggak ada, Pak. Data
Betul. Itu
persoalan.
sebenarnya saya pernah diskusi, makanya kita bilang tadi BPOM. Itu kan BPOM untuk
Nah,
yang
itu maaf Pak, itu karena kita sektoral. Badan POM padahal di situ ada perindustrian, Pak. Satu bahan kimia bisa ke perindustrian, satu bahan kimia bisa di Badan POM. Itu persoalan kita, Pak.
Iya, betul.
Apalagi kemudian Kemenkes terlibat lagi, kepertanian terlibat lagi. Semuanya punya hak pada satu bahan kimia yang sama. Saya pernah, karena saya pernah melakukan kerjasama riset dengan BPS, dengan kementerian terkait, itu Pak pusing mereka, Pak. Jadi ketika ada kasus ethylene glycol, ya, we have a problem with ethylene glycol as a solvent in drug, something like for children, drug for children. Dia butuh ethylene glycol. Ethylene glycol itu ada di industri, Pak.
Iya.
Tapi ada juga di Badan POM pengaturannya.
Iya.
Jadi kadang berapa yang diizinkan Badan POM, dia tahu nggak? Nggak tahu, Pak. Perindustrian nggak tahu juga. Perdagangan kok kami disalahkan kan gitu. Itu problem, Pak.
Iya. BPS nggak mendata, Pak. Jadi gitu.
Nah, that's the point, Pak.
Karena tadi sektoral, makanya tadi saya kasih gitu, Pak.
Iya, karena pengalaman saya sih kalau saya nyari data BPS kalau dulu ya, itu data itu kan tahun yang lalu.
Iya.
Bukan updating kan gitu.
Iya.
Makanya how about the big data in this case? Bisa nggak kita? Maaf ini saya jadi diskusinya agak ngantuk.
Betul, Pak.
Mungkin,
Terima kasih.
Makasih. Ya, makasih.
Terima kasih, Pak.
Ya.
Jadi let me just respond in bahasa again, Wayne. Very sorry, Wayne. Jadi gini, Pak. Terima kasih. Setuju sekali, Pak. Kami fokus untuk yang big data, untuk yang khusus. Nah, seperti statistik umum yang tadi growth ekonomi, karena pasti kebutuhannya pengennya cepat. Saya tahu gitu, cepat. Presiden itu mintanya ekonomi growth itu 35 hari. Itu PR banyak. Yang sekarang menjadi salah satu keberhasilan pemerintah adalah data KSA, data penantian pertanian, Pak. Dulu ada yang tahu, teman-teman tahu nggak? Luas area pertanian itu dulu Pak. Itu data pakai apa? Dihitung nggak? Nggak dihitung meteran. Tapi dia pakai apa? Apa Bu Siti namanya? Pakai ubinan, terus kita ngeceknya pakai apa? Dulu luas areanya. Pakai I estimate kan? Bapak ditanya luasnya tanah berapa? 5 hektar. Jadi kalau luas tanah itu di jumlah lebih luas daripada luas Jawa pulau. Karena semua pikirannya kan I estimate. Pikiran salah. Itu maka sekarang pakai teknologi, Pak, pakai KSA. Itu untuk memastikan matching datanya. Kementerian BPS dengan Kementan sama. Saya rasa itu salah satu contoh. Nanti teknologi kita pengen tadi barusan kemarin kita diskusi BPS itu berubah dari waktu kita diisi ini juga karena Bu Prof Titi ini kan kalau bilang Dewan Pengawas isi ya BPS juga. Jadi kemarin kita di waktu isi kan BPS ngubah dari apa? Dari pengakuan ke pengukuran, Bu. Itu makanya kita buat pakainya kan hati-hati, kita pakai citra satu itu udah nggak ada yang bohong kan gitu. Tapi memang harus pendekatan. Jadi seperti itu arahnya. Jadi memang arah ke sana, menuju ke sana untuk statistik yang umum tadi kita coba lakukan supaya cepat datanya. Nanti inginnya data yang kalau citra satelit itu kan bisa per bulan. Jadi kita bisa mendapatkan mapping per bulan juga. Gitu harapannya, inginannya. Gitu. Tentunya ya tadi dengan modeling yang ada. Seperti itu Pak, mungkin Pak Halding melanjutkan.
Terakhir pertanyaan
Ya.
saya, sudah ada inisiasi belum untuk membuat big data center yang benar-benar big data center itu punyanya government official gitu ya. Kalau di Malaysia itu saya pernah itu ya setiap negara bagian itu punya itu big data sama high performance computing facility-nya, centernya. Jadi memang terpantau semua itu pergerakan data, pergerakan manusia semua. Jadi, nah kalau di kita sudah ada ke situ Mak, ya. Misalnya kita kan luas sekali nih, paling nggak di negara Jakarta, kemudian di seluruh provinsi ada gitu ya.
Yeah.
Wah itu kan luar biasa nanti tuh bisa terpantau semua yang seperti racun-racun tadi bisa ke filter ya pergerakannya gitu. Nah dari BPS ada nggak itu
kalau
inisiasi ke negara gitu?
Okay.
Kalau di Taiwan, saya waktu ke Taiwan itu big datanya itu sama high performance computing facility itu langsung di bawah presiden. Di bawah ketiga kementerian di situ. Menteri Pertahanan, Menteri Riset, kemudian Kementerian Perdagangan kalau nggak salah. Jadi ada 3 kementerian. Pertahanan, Kementerian Pendidikannya, Riset dan Kementerian Perdagangan. Jadi itu big data center. Itu di 3 kota besar itu saya sempat mengunjungi di situ tuh.
Saya nggak diajak Pak.
Taiwan, Taichung, Tainan namanya. Wah, keren itu. Pulau sekecil itu mereka sangat kuat ininya. Big data dan artificial high performance computing facility-nya. Nah, di Indonesia seluas ini gitu.
Karena
Gimana tuh Pak Setia?
Oke. Kita harus bareng dengan
Kalau di Australia udah pasti ya. Saya waktu
ya.
kuliah Mr. Wayne, I'm a graduate from the University of Queensland ya. And when I did my PhD, we use high performance computing facility and we have access to Queensland high performance computing facility and also to Canberra ya for federal government. So in each state they have their own high performance computing facility and also in the federal government they have national high performance computing facility. This is why we can do a great job in our research. Oke, mungkin nggak tahu nggak inisiasinya dari mana ya, BPS apa tuh?
Oke, baik
mungkin
Pak.
dari BPS-nya kali yang nyundul ya.
Jadi gini, pertama terima kasih Pak. Jadi kan kita ada pusat gini. Data governance sebenarnya itu yang penting ya kan. Sebenarnya kalau kita bicara satu center tuh gini ya. Mungkin yang kadang-kadang teman-teman salah itu adalah teman pimpinan salah. Dipikir data center tuh datanya satu tempat. Itu nggak selalu kan. Dia sebenarnya asal dia connected aja nggak masalah. Saat ini di BPS Pak, jadi saya mau ambil di BPS dulu sebentar. Adalah sebenarnya untuk karena ini capturing big data, ini juga arahan dari Kepala BPS Pak Margo, kemampuan Pak Imam adalah rencananya akan ada satu direktorat khusus untuk big data dan data administratif. Itu salah satu tujuan, salah satu jadi goalnya dari Pak Margo ini ada beberapa 7 arah perubahan dan itu salah satunya nanti menjadi. Tapi memang merubah susah juga kan atas RB dan sebagainya, itu udah satu. Kemudian saya setuju sekali kalau misalkan di dalam internal BPS sendiri kita ini saat ini ada yang disebut single source of truth di dalam BPS sendiri. Data itu semua dimasukkan ke sana, nanti semua bisa akses. Karena pentingnya satu data itu kan satu data yang dimaksud dengan tadi Prof. Al-Hadi adalah tadi kan satu tempat yang bisa diakses orang semua, infrastruktur di situ. Kita juga itu pengennya waktu saya di Eropa juga begitu gampang. Tapi ternyata memang masih arahnya ada namanya Pusat Data Nasional kan PDN, tapi saya rasa itu masih long way juga ke sana. Yang saya diskusi kalau yang terkait sama Kementerian Kesehatan, baru kemarin Pak 3 hari saya kemarin ketemu Pak Setiaji dari DTO kan. Ini gimana datanya genom, terkait genom. Ya masih arahnya pengen ke PDN Pak, pengen ke sana. Tapi ya sampai saat ini belum. Tapi arahnya nanti di PDN itu yang menjadi Pusat Data Nasional, Big Data Resources di sana. Arahnya. Sementara ini kami pakainya untuk BPS sendiri, itu datanya ada satu di kita, sebagian kita masukkan ke cloud, data yang bukan data, kalau regulasi kita kan data itu semua sudah di on-premise di Indonesia. Kecuali data yang kita ngambil, yang tadi kita ngambil data publik itu nggak masalah, karena nggak keluar dari scope itu. Nah kita pakai on cloud itu. Nah itu nanti semua bisa diakses oleh kita, oleh teman-teman dari yang lain dari luar tim gitu. Seperti Pak, tapi PR-nya adalah tadi Pak, saya senang sekali juga. Ininya saya ini gini Pak, akademisi, tapi di BPS juga itu, sehingga juga greget juga nih gimana datanya nih. Dan saat ini kalau makanya tadi saya very open kalau nanti semua kami dikritisi gitu kan, saya juga sebagai akademisi pengen mengkritisi kan. Kami saya juga inginnya dikritisi. Nanti kalau ada kerjasama, very welcome. Harusnya seperti apa kami diinformasikan, tapi tadi di scope yang kegiatan kami saja gitu. Tapi kalau untuk riset Pak nanti saya diajak Pak kalau di riset terkait dengan bioinformatics dengan apa tadi yang terkait dengan hazard toxicity itu. Dulu saya ini Pak, saya tuh sebenarnya dulu drug response Pak, toxicity belajar, PKPD saya belajar dulu Pak. Jadi pengen balik lagi ke habitat Pak sebenarnya. Terus saya diajak Pak. Terima kasih.
Thank you, Prof. Setia, for the response. I think that I can see that we are moving towards a really heated discussions. Turns out lots of problems that we have that we need to discuss, but unfortunately we have limited time. And yeah, our two speakers also have several agendas. So I think that we should conclude our meeting for today, our session. Maybe just a closing statement like the last, what is it, student asked about, is there everything can be explained by data? Maybe I just read one interesting statement somewhere. It says that in God we believe, for others bring your data. So although nowadays probably we can't explain it, but just like Prof said before, more probably not, but not yet. Somehow, maybe somewhere, sometimes later in the future, you can explain that thing that's unexplained nowadays. So I think that's all, and let's give a big round of applause for our two speakers. And then, yeah, I just like to deliver the chance to our master of ceremony.
Thank you very much, Ibu Sarini, and also thank you very much to all of the participants. The discussion between Professor Al-Hadi and also Dr. Budiawan, and of course our incredible speakers and moderator. So that marks off the end of our discussion session. And of course, to show our gratitude to our honorable speakers, I would like to invite Professor Al-Hadi and Dr. Budiawan to come forward so that we can show the token of appreciation to both of our speakers.
Oh, oke. Nanti yang tadi yang berhak dapat buku dari Prof Setia satu, katanya nanti saya yang tentukan. Waduh. Kayaknya tadi penanya pertama deh, boleh. Ya, James ya, nanti dapat buku dari Prof Setia. Tapi untuk yang 3 yang lainnya juga nggak apa-apa lah, hadiah tambahan dapat buku dari saya. Promo. Nanti boleh ke ruangan saya ambil. Ya, oke. Demikian tambahan informasinya.
Okay. So thank you, Professor Al-Hadi, and also Dr. Budiawan for giving the token of appreciation. So that marks off the end of this event. I would like to express my gratitude for our beloved participants too, who have attended and participated in this lecture. I'm Adawiya, as your Master of Ceremony, would like to say thank you very much for being present today. I wish you all a great day ahead. Good afternoon and see you on our next events. Wassalamualaikum warahmatullahi wabarakatuh.